This lesson is part of Module 2 of the SaferAfrica Road Safety course. The module is focused on data, data collection, data management, data analysis and the relation between data and road safety policy making. The module is based on information from different courses and put together for the EU Safer Africa project. The course will be presented by Martin Navabi-Niaki and Henk Stipdonk. You will hear our voices mostly, so in case you wonder who you are listening to, we'll introduce ourselves briefly.
Thank you, Henk. This is Martin Navabi-Niaki. I will be presenting part of the lecture today, and I work at SWAV as a researcher. My background is in civil engineering, and I focus mostly on cyclist safety. In the final session of Module 2, we will discuss policymaking based on data. Of course, actual policies for your country have to be based on analysis of your own data, and we cannot consider these data in this course. Instead, we will show some examples of policy decisions that could be made or have been made based on data analysis. We will show some examples based on Dutch data, New Zealand data, and Cameroon data. We will close the session with some general remarks and tips. First, we will show some Dutch data and describe the relevant road safety policies that can be derived from these data. As a first example, we will revisit one of the slides that were shown in session 2 of this module regarding risk for different age groups and different travel modes. Let's first take a closer look at the relevant figures.
Now it's time for a small exercise. We suggest that you look at those graphs and think about it some more. What can you see there? And well, in a minute we'll discuss the results. We suggest that you now pause the video for a few moments. As you can see from the graphs, the highest risks are for the people with highest age, 80 or over. But fortunately, their distance traveled is very small, especially for the high-risk power two-wheelers. We hardly have any people over the age of 80 who are traveling on a power two-wheeler, which is fortunate because their risk is really very extremely high. Then we see children in traffic. They're quite well protected in the Netherlands, and especially when they're inside a car, as you can see here, they have a very low risk, especially as compared to the car occupants between 15 and 30. They have a rather high risk, which is much more pronunciated for car as it is for pedestrians or cyclists. And then we see quite a low risk for the 30 to 60-year-old, well, for all travel modes actually, and then it's increasing for 60 plus.
So what policies can be derived from this graph? First, we notice that car occupants are well protected and much safer than the other travel modes. So any shift from the other modes to driving would be an improvement. For motorcycle riding or moped riding, this would be an attractive policy. However, cycling and walking are not easily replaced by car driving, so we need to look at a different option. The policy that was chosen in the Netherlands and some other countries was to ensure the presence of safe sidewalks for pedestrians along every road and a safe crossing facility at locations where pedestrians must cross to the other side to continue walking. And finally, for cyclists, a similar improvement is possible, namely a separate bicycle facility along the roads. Looking at age, we denote two problems. One is with young car drivers, and the other is with the elderly. In some high-income countries, projects have started to help young drivers gain experience by allowing them accompanied driving until their 18th birthday. In this approach, they can start driving at 16, 16 and a half, as long as there is an experienced adult on the passenger seat giving them feedback to the young drivers. A solution for the elderly is more difficult, but we do have the policy to allow elderly drivers to continue driving as long as possible, even when slight deficiencies such as dementia start to develop. Once an elderly person is no longer allowed to drive a car, he or she might switch to a more dangerous vehicle, which has to be delayed as much as possible.
This graph shows the number of reported road deaths by age group in 5-year groups in 20 different panels from left to right and from top to bottom. Here we see children of 0 to 4 years old. Here we see 5 to 9 years old. Here 10 to 14. Here 15 to 19. And then on the next line we see the next 4 groups, and then another list of 4 groups, and then the last 4 groups, and the last one is 75 plus years of age. All graphs are in the same scale, so the vertical scale is the same for all, and so the differences in the graphs are entirely due to the different numbers of people killed in those age groups. The different colors represent different travel modes. So here we have the light green are pedestrians, and then cyclists. The third group is moped, the fourth is motorcycle, and then passenger car, and on top is a very thin layer of other travel modes, which is hardly important. And as you can see, the trends in the number of people killed by age group and by travel mode are strongly different over the years. Remember that here we have on a horizontal scale the years ranging from 1950 at the left and 2012 to the right. So we have 60 years of data here. And as you can see, the number of people killed as young children has been rather high up until 1970, and then decreased very quickly until there are hardly any people killed at that age nowadays, as compared, for example, to the 75-year and older, where still, well, more than 100 people killed annually in those age groups. And you can see that some are pedestrians, some are cyclists, quite a lot actually, and the remaining are mostly occupants of passenger cars. And here again, there's a lot that can be seen, and I would like you to form an opinion on this graph and think about it again sometime. Pause the video and think about it, and take a closer look and see what you can learn from this graph. There are always explanations behind those data, and we will get to the demographic issues in another part of the module 2.
These graphs show mortality instead of deaths. So here we see the number of deaths per million inhabitants of each age group. This graph corrects the number of deaths for differences in population size and for changes in population size over time. Now, what policies can be implemented based on these developments over the 60 years? Many children were killed as pedestrians between 1950 and 1975. Children below 4 years of age, of course, did not travel as pedestrians. They were probably playing in the streets, and so many playgrounds were built in most municipalities to effectively guide children away from the road. For elder children, safer roads around primary and secondary schools were built, such as 30 km/h roads, and separate bicycle paths were built along routes to the secondary schools. In the age group of 15 to 19 years old, the majority of deaths were moped riders. By introducing the compulsory moped helmet, moped riding was essentially reduced and safety was improved. The general decrease since 1972 is mainly due to the increased driver experience and improved car safety. The most important contribution of the Dutch policymakers was the introduction of the safe system approach in the 90s. We have also seen this graph in session 2 of module 2. I want to show you this graph because it led to an important focus on the safety of roadsides. As you can see, one of the groups with many deaths and a slow decrease is the group of single vehicle car crash deaths. The number of deaths in single vehicle crashes is higher than the number of car occupant deaths in all other crashes together. Once it became apparent that this group of crashes was relatively immune for policies focusing on two-vehicle crashes, both provinces and the national road authorities decided to improve roadside safety in several ways. I believe that in many low-income countries, roadsides are still extremely unsafe, such as these unprotected drains and broken covers of such drains in the middle of the road. What if a power two-wheeler does not see these potholes at night or when they are filled with water in the rain? We may miss many of those crashes in the police database and hence mistakenly simply ignore them in policymaking. Now some examples from New Zealand data can be shown where policy was derived from data analysis.
This is a graph that is much alike the graph you just saw for the Netherlands, but this one is for New Zealand data and people of New Zealand killed in road crashes. And I want to show you this because it is a nice way to illustrate what can be learned from stratifications of road death data. As you can see, in New Zealand there was a strong decrease in the number of people killed around the 90s, as shown in this lower right graph, the white one, which shows the total number of people killed in New Zealand. And this sharp decrease is not, as you might think, the direct consequence of successful road safety policies, although there may be successful policies there. But this decrease can be attributed to a specific decrease in the number of people killed as power two-wheelers, as motorcycle riders, as you can see on this line over here. We see that the total number of people killed as a motorcycle rider has strongly decreased in the 90s, much stronger than all other crashes. And when we asked around in New Zealand what happened and what they did in that period, the answer turned out to be that they introduced the introduction of second-hand cars that were imported from other countries, from Japan mainly. So this is the period where people started to switch from power two-wheeler riding to car driving in great numbers. So effectively this decrease is because people stopped using the power two-wheeler as the regular means of traffic.
So in fact, while in the 90s the number of power two-wheeler crash deaths decreased drastically, the number of crash deaths for cars leveled out somewhat. So the net result is advantageous to the total. This illustrates that a shift from power two-wheelers to cars, even if these cars are not the safest, is still a good policy to improve road safety. Finally, we will give some more speculative examples based on some Cameroon crash data.
This slide shows death and non-fatal crashes during the day, for the different hours of the day. There are one or two remarkable properties of this graph. Take a minute to see what you can say about it. If you want, you can pause the video. So one of the first things you can see that is that the distribution of the number of crashes over the hour of the day are virtually the same for non-fatal crashes to the left and fatal crashes to the right. And also you can see that the distribution of workday numbers, which are open symbols, is virtually the same as that for weekend days, the gray ones, both to the left and to the right. So there's not much need to make a difference between to make a distinction between work days and weekend days if you're doing the analysis, because it looks the same. Further, you see that the number of crashes is equal in both panels, left and right. This suggests that serious injuries are not very well reported, because we expect much more non-fatal crashes than fatal crashes. And which means that all those people who are in a crash but do not die on the spot are likely to be missed in the reports, because so many people who are not killed on the spot are missing in the reports anyway. Further, you can see there's a funny dip in the graph around 7 in the evening, after which the numbers rise again. That is over here and over here. This could indicate, well, this could indicate anything. We do not know from the data what it means, but we could guess and then do research and try to find out what's going on. It could, for example, it could mean that the rise after 7 is because people, well, have had their dinner and then start traveling again. It could also mean that they do not start traveling again, but because it's dark after 7, the danger is higher. There's another possibility that there's alcohol in the blood in drivers after 7, and that could explain the risk. It could even mean that at around 6, police is busy managing the traffic and has no time doing crash reports. There is also a dip around 1 p.m. as well, right here and here. Again, we don't know. We need to find out. It could be related to people having lunch. It could be travelers. It could be the police. So these graphs illustrate that explanations of observations may have to do with travel or with risk, and we need to do additional research to find out, at least if you want to develop policies to improve road safety.
My suggestion to policymakers based on this graph would be to do the following. Make strong efforts to improve road crash police report rate. Research why crashes are not reported and remove the obstacle so as to increase the recording of crashes. Research if crash report rates are lower around lunchtime and around dinner time. If so, remove the obstruction there and ensure improved report rate independent of the time of day. Research if crash after 7 p.m. are caused by dark or by alcohol and develop a program to solve this problem. This may require improving roadside improvements, street light, vehicle light, enhanced alcohol or speeding enforcement, etc.
Here on the left we see the age of the casualty on the horizontal axis for drivers, passengers and pedestrians, shown as different symbols. And in the right panel we see casualties by age for all relevant travel modes. And again, take your time and take a look at those graphs and see what you can deduce from them. You can pause the video if you want. As you can see, the left and right figures are different, although from the same database. The left graph may show the victim always, while the right may show the other party sometimes, because these are databases containing records for every person involved in a crash. It could be the fatality, it could be someone else involved in the same crash. Further, we see that pedestrians in the black dots are often involved in a crash when they are young, much more than when they are older. And of course, it's not very surprising because pedestrians of 5 years of age have no other means of transport, at least by themselves. So they're on the road as a pedestrian, but not so much as a car driver or a motorcycle rider. Further, we see motorcycles often involved in a crash. To the right, a very high peak of data of motorcycle riders. Well, doesn't surprise us, motorcycle riding is very dangerous. And given the number of motorcycle riders in Cameroon, I would have expected a much higher peak, but it isn't there. It may have to do with underreporting of motorcycle rider crashes. Then we have zero age and unknown age, and they may be mixed up here because here we see 0 and 0 for work vehicles and for other, and other suggests that we do not know the travel mode, and the fact that there are so many people of those travel mode with a 0 age, there's reasons to suspect that 0 age is mixed up with unknown age. Further, we see that the number of victims among riders increases with age and then decreases. What could be the reason for that? So I mean, this upward slope and then this downward slope. What could be an explanation for that? You may pause if you want, but I'll give the answer straight away. My guess of the explanation is that the amount of travel increases with age in those age groups. So this increase is explained by the increase in the amount of travel among those ages, whereas in the age group between 30 and 50, it is not the amount of travel that is decreasing, but it is the experience of the rider that is increasing, and therefore causing a decrease in the risk and a decrease in the amount of people being involved in a crash.
Now, what road safety policies emerge from these graphs? I have the following suggestions. Pedestrian safety for children is a serious problem. I would strongly advise to improve pedestrian safety, especially around schools and on routes towards schools. Make sure children do not have to cross unsafe streets when walking to and from schools. Research if the number of deaths for powered two-wheeler riders is indeed following travel. As suggested, the decrease in the number of deaths on powered two-wheelers may be a consequence of improved experience. An alternative explanation may be that this is caused by a gradual exchange between powered two-wheelers and cars, because we can observe that the number of deaths in cars does not start to decrease with age until at the age of 55. There is a relatively large number of deaths in buses. Now, one would expect that when bus companies take the trouble to facilitate safe travel, these numbers would be drastically less. My research question would therefore be if these deaths are much better reported because a crash with a bus involves many deaths, or is it simply because buses are unsafe? And I would strongly advise to improve public transport safety because this has immediately reduced the risk of crashes with many deaths and therefore be relatively effective.
We now come to the final part of this lesson.